व्हाट्स अप बच्चा पार्टी। दिस इज अंकित फ्रॉम इकोसीखो एंड हम लोग आ चुके हैं एक नया सीरीज के साथ जिसका नाम है मैथ क्विज विद अंकित सर। ठीक है। सो मेनी अ टाइम मैंने अपने इकोनॉमिक्स के स्टूडेंट्स एंड अपने मैथ्स के स्टूडेंट्स को बेसिक बेसिक मैथ्स के प्रॉब्लम्स को सिंप्लीफाई करते हुए जो कुछ भी कंफ्यूजन है उसके साथ जूझते हुए मैंने देखा है। सो मैंने सोचा कि क्यों ना एक नया प्लेलिस्ट स्टार्ट किया जाए जहां पे हम लोग कुछ भी कॉम्प्लेक्स चीजों का कैलकुलेशन को बहुत सिंप्लीफाई करने का कोशिश करेंगे। ठीक है। सो विदाउट एनी फर्दर अड्यू स्टार्ट करते हैं एंड कोशिश करेंगे पूरे के पूरे वीडियो को हम लोग विद इन 10 मिनट्स खत्म करें। सो इस वीडियो का ऑब्जेक्टिव आप लोग को ऑलरेडी पता है। वी आर गोना ट्राई टू फाइंड आउट द स्क्वायर रूट। ठीक है, यूजिंग द लॉन्ग डिवीजन मेथड। ठीक है। सो बिफोर वी जंप ऑन टू फाइंडिंग आउट द स्क्वायर रूट यूजिंग द लॉन्ग डिवीजन मेथड, चीजों को ऑब्जर्व करते हैं। ठीक। लेट्स से अगर मैं आपसे पूछूं व्हाट इज 8 स्क्वायर, तो आप मेरे को 64 बोलोगे। अगर मैं आपसे पूछूं व्हाट इज 12 स्क्वायर, तो आप मेरे को 144 बोलोगे। ठीक है। तो ये 8 स्क्वायर की तरफ ऑब्जर्व करिए। जब कभी भी आप एक नंबर को स्क्वायर करते हैं ना, तो बेसिकली उस नंबर में जितने भी डिजिट्स होते हैं वो सारे के सारे डबल हो जाते हैं। मतलब अगर ये पहले एक डिजिट था तो ये आफ्टर स्क्वायर बिकेम 2 डिजिट्स। सिमिलरली अगर 12 स्क्वायर को मैं देखूं तो ये 2 डिजिट था, लेकिन आफ्टर स्क्वायर इट बिकेम 3 डिजिट। ठीक है सर, आपने तो कहा था डबल हो जाता है, तो यहाँ पे पहले में एक जीरो को ऐड कर दीजिए, तो इट बिकेम 4 डिजिट्स। ठीक है, बिकॉज 0 1 4 4 एंड 1 4 4 इज द सेम नंबर। ठीक है। एंड यूजिंग द सेम लॉजिक आप किसी भी नंबर के साथ चेक करिए कि वेन एवर यू आर डूइंग द स्क्वायर का मोस्ट ऑफ द टाइम डिजिट्स हो जाता है, द नंबर ऑफ डिजिट्स बिकम्स डबल। ठीक है। तो यूजिंग द सेम लॉजिक अगर मैं आपसे पूछूं 789 का स्क्वायर कितना है, तो यहाँ पे भी आपका आंसर होगा 6,22,521 एंड द नंबर ऑफ डिजिट्स वी कैन सी हैज बीन डबल्ड। ठीक है। सो इनिशियली वी हैड 3 डिजिट्स बट नाउ आफ्टर द स्क्वायर रूट आफ्टर द स्क्वायर वी आर नाउ हैविंग द डबल नंबर ऑफ डिजिट्स। Similarly, if I ask you to do 234 square, so you will find the answer has to be 54,756. So the number of digits has like almost doubled. Okay, we can always add a zero in front of the entire number set and we'll still get the same number. Okay, so using this same concept and same logic, let us try to find out the square root of random numbers using the long division method. Okay, so first, let me try to find out the square root of 4,321. Okay, so your basic common sense should say you that, sir, whenever you do the square, you get the double number of digits. So similarly, if you do the square root, you will get half of the number of digits. Okay, so that's what exactly I'm gonna do. Okay, so if I want to find out 4,321, so what I will do is that I will divide the number into pairs. Okay, starting from the right hand side, I will divide the numbers into pairs. Okay, so 43 over here. Now let me think of a number. Okay, so 6 square will give you 36. 7 square will give me 49. Okay, so 7 square 49 is a number which is exceeding 43. So I will not consider 7 square. Instead, I will consider 6 square. Okay, so 6 square, I will put a 6 here and I will put a 6 here. And 6 square is 36. It leaves me with 7. Okay. Next, what I will do, I will bring forward the 21. This entire thing got carried down. Okay. Next, I will add this 6 with this 6 and I will write 12 here. Next, what I will be doing is that I will think of a number. Okay. I will be thinking of a number that can be added here and the same number should be added here as well. Okay, so let me think of a number, let's say 123. So 123 multiplied by 3 will give me how much? It will give me 369. So 369 is a number that is way below than 721. So I need to think of a bigger number. Let me multiply 125 by 125. Okay. So if I try to do 125 by 125, that will give me 700. So 125, 5 is a, will give me 5 over here, and it will give me 2 and 625. Okay. So let me put a 5 over here. So 125 and 5 comes here, and I will get a number 625. Okay. So if I subtract, I will get 96. Okay, and the same logic will happen here. I will add this 5 here and that will give me 130. Okay, but now I cannot think of a number which has a pattern 130 dash into the same dash will give me a number which is smaller than 96. So what I will be doing next is I will be putting a point here, and once I put the point here, it gives me a power to bring two zeros here. Okay, so next I will be multiplying 130. Okay, so I will be multiplying 130. Let me make it 1307, and let me multiply it with 7. So that will give me 49, and 7 3 ja is 21, 1 2 carry, and 9149, which is a number less than 9600. So let me put the 7 here and the 7 here. So it will give me 9149. And after subtracting, I will be getting a number which is 451. Since I have already put in as point, I can further add two zeros here. So whenever I will bring anything down, it will always be in terms of a pair. Okay. So the 7 that I added earlier will be added here once again. And now I will be getting 1314. Okay. So I need to think of a number that will be that we will put in this dash over here, and the same dash will be filled up over here. Okay. And so let me just try. Okay. So 13143 into 3. So remember one thing, the same number will be put over here and here. Okay. So if I do this two multiplications, I will be getting how much? It will be 9. Then I will be getting 2, 4 3 are 12, and 1 carry. Then I will be getting a 4. Then I will be getting a 9. And finally, I will be getting a 3. Okay. So let me put this 3 over here and this 3 over here. So finally, I will be getting 39429, and this can keep on going. But I will just stop here. Why I will stop here? Because I have gotten my answer. The square root of 4321 is indeed 65.73. So see, that was so easy. Right? Just to clear your doubts further, let me do a few more questions and we will be clear with everything. Okay. So this method of finding out the square root is known as long division method, and it can come quite handy. So let us try to find out the square root of 91 using the same logic that we have done so far. Okay, so 91, we will write it in this form. And we'll make pairs. Okay, so 91 is the only pair I can see, and I'll think of a perfect number, a perfect square number before 91, and that brings my attention to 9 square, because 9 square is 81. Okay, so I will put a 9 here, I will put a 9 here, and I will put 81 here. That leaves me with 10. The 9 that I put on the top will now be added here, and that will give me 18. Okay, and next what I will be doing, I will be putting a dot here, and putting a dot here will give me a power to bring two zeros. Okay, so next I need to think of a number x that can be put here as well as here, and multiplying this 18x with x will give me a number less than 1000. Okay, so what that number can be? Okay, so let me try with 5. Okay, so if I multiply 185 with 5, I will be getting 5, 2, 2, 4, and 925. So instead of x, let me write down 5. So 5 comes here, and I will be getting 925. That leaves me with 75. And since I have already put in a 0 above, I will be now bringing down two zeros. And this 5 that I had written here will now be added. So that will give me 190. Now I will be thinking for a y. This y will be put here as well as here. Okay. So 190, and I will be adding a digit. Let me try with 3. Okay. And it will multiply it with 3. So it will give me 9075709. Okay. So a 3 goes here and a 3 goes here. And I will be getting 5709. And this keeps on going. I can stop here. Okay. So I hope that was clear. So it depends upon how many values, how many decimals after the point I want. Okay. So in most of the cases, we are done with having only two digits after a decimal. So the square root of 91 is 9.53. Okay. So let us try with the third example. Okay. So how will you find out the square root of 5? Okay. So same logic. I will be making a box and I will put here. And we will be making a pair. Okay. But 5 itself does not complete a pair. So we will be adding a 0 in front of it. Now 0, 5 is a pair. And the perfect square before 5 is 4. Okay. So I will be putting a 2 here and I will be putting a 2 here. That gives me 4, and I will subtract it. That leaves me with 1. Okay, next what I will do is I will add this to the two that I have written on the top. I will add it. So after adding this two over here, I will be getting a 4. Okay, so next I will think of a number x that can be put here and here, and this 4x will be multiplied with this x, but the multiplication should be less than 1, and there is no such number. So what we will do before proceeding, we will put dot here, and this dot gives me a power to summon two zeros. Okay, now I will be thinking of a number. So 42 times 2 seems good number. Okay, so let me do 2 put here, and let me put a 2 here as well. Okay, so 42 times 2 will give me 84. And after, yes, I guess, yeah, it's 84 then. Right. So that will leave me with 16. And what I will do next, since I had already put in a decimal over here, so I will now summon again two zeros. And this 2 that I had written earlier, this 2 will now be added here. That will leave me with 44. Next, I need to think of a y that can be put here as well as here, and I will be able to multiply 4y with y, and the result should be less than 1600. So I need to think of such a number. Okay, so the number that comes into my mind is 3. So let me put a 3 here, and let me put a 3 here. So 443, 3 ja will give me 9. It will be 2, 1 carry forward, 1329. Let me put it here, 1329. And this thing will keep on going. But I have gotten my answer, which is 2.23. So the square root of 5 is 2.23. So I hope it was clear. Let's move to one more question. So let's say I want to find out the square root of 0.1. Right. So to find out the square root of 0.1, let me make a box and put things under a pair. Okay. So sir, how will you put a pair over here? Okay. So kids, remember one thing. Okay. Let me write it down here. I'm unable. Yes. Tell me one thing, 0.789 and 0.7890. Is there any difference between these two numbers? The answer is no. There is no difference between these two numbers. Why? Because, sir, if you keep on putting zeros towards the last of a number that is in decimal, the number does not change. If I keep on putting a 0, 0, 0, 0, it's still the same number. And by using the same logic, if I keep on putting a 0, 0, 0 on the front, the number is still the same. What I want a pair. Okay, so what I will be doing, I will be putting a 0 here, and I will be putting a 0 here. So this is a pair and this is a pair. So whenever I want to search for a pair from the decimals point of view, if I am looking at the numbers, I will be going towards the right and I will be going towards the left. So for this, I will be going towards the left, and for this, I will be making the pairs from the right. Okay, so let's say if I want to find out the square root of 513.789. Okay, so what I will be doing, I will making this as a pair, I will be making this as a pair, I will be making this as a pair, and I will be making this as a pair. So I moved in this manner. Okay, so using the same logic, if I want to find out the square root of 0.1, so let us find out. Okay, so 0, zeros are will give you 0, and you are left with nothing, and you will be adding the 0, and that will be 0 again in itself. Okay, so next I will be adding a point. This point gives me a power to summon whatever there is towards the right of the decimal, and now I can summon a 10. So I need to think of a number that I can add here as well as here. So 0.3 into 3 will give me 9. Okay, and that leaves me with 1. And since a point, a decimal already exists, so I can again summon two zeros. And this 3 will be added here. So I will be getting a 6. So what I can do next is 61 times 1 will give me 61. And I will be left with 39. Since a decimal already exists, so I can summon two zeros. And this one that I added, that I wrote above the table, will again be brought here and it will be added 62. Okay, so I need to think of a number that goes here as well as here. Do I need to proceed this much? No, I think we have got our answer, because we are generally interested in numbers that is like two places up to decimal. Okay, but if you want, you can proceed further as well. Okay, and with this, let us do a one last question. And The last one which I want to discuss is 0.3045 and 7. Let us try to find out the root over of this number. So this can be found out. Let me make 0.30457 and let me do the pairing this and this. Okay. And the number before is point is 0 already, so I don't need to bother about it. So I will simply start with 0 point, and adding a point gives me a power to summon 30 and to look at only 30. Okay. So what I will be doing next is I will be adding a 5 here and a 5 here. That will give me 25 and I am left with 5. And since I already have a point, I will now summon 45. And this 5 that I have written on the top of the table will be added here and I will be getting a 10. So next I will be writing a 5 here as well as a 5 here. So this becomes 525 and I am left with 20. And this gives me a power to summon 70. Okay. And this 5 will be added here and I will be left with 100. Okay. Next, what I can do is that I will be adding a 2 here and I will be adding a 2 here. That gives me a power to write 2204. I believe 2204. Yes, that's a number bigger. So let me write a 1 here. So 1 and 1 here. So that leaves me with 1101. Okay, so that's how much 69 and 9. Okay. And adding the 1 here, I will be getting 1102 dash. Okay. Now, sir, what can be done next if we still want to find out the rest of the decimals? So since you have already written a 0 point a decimal, and you can add on as many zeros as you like. It doesn't really matter. Okay. And you are done. So the square root of 0.30457 is 0.551. Okay. And yeah, that was about it. Okay. Now, if you have observed closely, I was decreasing the numbers as I was doing the numbers. Okay. So I did the square root of a 4-digit number, then I move on to a 2-digit number, then I moved on to a 1-digit number, then I talked about a decimal number which has only one place in the decimal, then I talked about a decimal number which has 5 places in the decimal number. And if I still try to go below, the next number should be root over minus 91. Right. Sir, how will you find out the root over of minus 91? So, guys, this actually is an imaginary number. The square root of a negative number does not exist. Okay, so we won't be able to find this. Okay, so I hope with this video you are clear with the long division method and how to find out the square root of a long division of any number. How to find out the square root of any number using the long division method if you don't have the calculator with you at the moment. Okay. So that was all from this video. And if you have understood this video, I want you to comment what will be the square root of 11. Okay. So yeah, that's all for now. See you in the next one. Thank you so much, everyone.